Alright, our summative review for Unit 5. Question number 1 says Miss G has 15 fun treats for her student. She has 6 stickers, 3 buttons, 4 candies, 2 pens. Student's in pot was probably that they get a sticker. We got a sticker or gel pen. So we're looking at sticker and a gel pen. Stickers is 6, gel pens is 2, 6 plus 2, 8 out of 15. Made a matrix from last year. There's the results. This year says period 5 and period 7 classes have twice the number of A's, so that's times 2, and half the number of C's. So we're going to divide that by 2. We want a new matrix, so we have period 1, period 5, period 7. We have A, B, C, D, E. A's is times 2, so that's going to be 20, 12, and 6. B's doesn't change, so it's 5, 10, 15. C's is half, so 6, 6, and 5. We divide each of these by 2. And D stays the same, 2, 2, 5, and E's also stay the same. If a student in period 5 is selected, so a student in period 5, here's period 5. What's probably he or she will have a B. Here's B, so it's 10. We add these up, that's 18, 22, so 10 out of 22. We can also say it's 5 out of 11. How many E's has Mr. Laguerre given out in the last 2 years? This year is 4. This year is 4. Well, 4 plus 4 is 8 E's total. Question 3. They want to conduct a survey to determine how many customers see the advertisements for a store. Which of these provides with the most representative sample? Survey customers who live near her store. Survey customers who shop at her store on the weekends. Survey customers who shop at her store early in the morning. Or survey customers who shop at her store at different times throughout the week. So I would say, and if she surveys the customers that shop at different times throughout the week, they would be her customers that would see the advertisements. Not all of her customers live near the store, so they might not see the advertisements. 5 of Kyle's scores from science are 89, 67, 100, 83, and 96. What's the mean and the median? Well, we can simply find the median by putting our data in order. So we know that the median is 89. To find the mean, we add them all up. This is a little bit smaller. All right. So we have 67 plus 83 plus 89 plus 95 plus 100. We hit enter and then we divide it by 5. So we get an average. Our mean, the average is 86.8. Next question says, if Kyle retook the quiz with a score of 67 and got an 88, what is Kyle's new mean and median? Well, so we're taking this one out and we're replacing it with an 88, so he retook it. Change that. So we retook it, so that means these just two are going to flip. So we'll have 83, 88, 89, 95, and 100. The mean stays this, or the median stays the same, but the mean will change. Because we know it's going to change. We know that the mean is going to increase because he went from a 67. So what we can do is we know that we have 434. That was the total. So we can get rid of that 67, but then we change that 67 to an 88. So we're getting rid of the 67, but we're adding in the 88. So it gives us a new total of 455. Now we divide that by 5. So his new mean is a 91. Now, did the mean or the median change? Why or why not? Well, the mean changed. The mean changed. and it changed because the mean is the average, and the 88, the 67 changed to an 88. So the average will also increase. The median's the middle number, and we just switched some numbers in the lower half of the data. It doesn't change the middle number. Ms. Gross wanted to know what percentage of students at Newport Mill have a computer at home. She surveyed all 150 of her students. Which of the following statements best describes why this sample is biased? The sample size is too small. Our students are required to take a computer class. Students may not have Ms. Gross that quarter. All students do not have the same chance to be surveyed. Well, all students don't have the same chance to be surveyed. She is only serving 150 of her students. So the students that don't have Ms. Gross that quarter can't be surveyed. So they don't all have the same chance. There's 30 people in the World Studies class. The table below shows their scores on the last test. Find the median of the scores of the students in the class. So what we know is that the total is 30. So we know that there's going to be 15 on this side and 15 on this side. So we want the 16th number because we want 15, or we want to be in between the 15th and the 15th number. So we want to find the 15th and the 16th number. So just by looking at it, we know it's 95 because there's 12 and then 8, so that gives us 20. But the other way that we can do it is we can simply find it using our calculator. We go to stat edit, and we have 100, 95, 87, and 79. And then our frequency is 12864. So we want to do stat calc. We want number 1. We want L1, comma L2. Enter. And it'll give us our median, which is 95. So we know that we want 15 on one side, 15 on the other. So the 15th number is going to be in 95. So that is the median. Joey's build your own sandwich shop. Well, we know that there's 3 types of bread times 2 types of cheese times 4 toppings and times 4 different meats. So we do 3 times 2 times 4 times 4, which three times 2 times 4 times 4, 96. So there's 96 outcomes. A recent survey said that 80% of Americans are registered to vote. Describe a model. This is a simulation. So simulation, well, we know that 80% is the same as 8 out of 10 or 4 out of 5. So we want something that's 8 out of 10 or 4 out of 5. Well, if I use my numbers 0 through 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, 8 out of 10 would be, so 0 through 7 is to vote, and 8, 9 is not registered. Or that's one way, or we could have did a say these are 5 equal sections, so we can say vote, 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 and vote, no vote. So we have 4 sections for votes, registered to vote, and 1 section not registered. Look at the shaded quartile of the box and whisker plot. The size of the shaded box shows that there are less scores in this quartile, Well, we know that all the quartiles have the same amount of scores. The size of the shaded box shows that there is the most variability in this quartile. Well, the shaded box is the smallest, so it doesn't have the most variability. It has the least amount of variability, and we don't know what the mean is. So the answer number 9 is C. That shaded box shows the least amount of variation. Number 10, Terry was asked to survey the speed limits. Alright, so Terry was asked to survey the speed limits of vehicles on Route 20. The table shows the results of the survey. Based on the results, what is probability that the next vehicle that passed by will have a speed of less than 35? Well, here's 35. Less than is going to be 16 or 18. So we have 16 plus 12, which will give us 28. And then we have out of a total of 50. So divided by 2, we get 14 out of 25. A company manufactured toys and assembled 500 toys. 6 were defective. They manufactured 10,000. So 6 out of 500 is equal to X out of 10,000. So we can simply cross multiply. So we can do 6 times 10,000. That'll give us 60,000, and then divide that by the 500. So X would equal 120 toys. The graphs below show the number of residents in town A and town B. The two, they have comparable populations. The mayor from town B used graphs to claim that there was a larger increase in the number of residents in town B than town A from these years, according to this information. Which of these explain why the graphs are misleading? A, the time periods are different. Well, we know the time periods are the same. The types of data are different. We know the types of data are the same. The vertical scales are different. Well, now if we look at the vertical scales, well, they are different, which is a reason why these graphs are different. And the populations of the town are different. Well, the populations are relatively the same. So the answer is C, the vertical scales are different. 13, a music video company waits to hire one pair of dancers from the television show Dancing with the Stars. After the pairs performed, they were rated by 1,000 audience members on a scale of 1 to 10. The ratings of the two pairs are summarized in a box and whiskers plot. Use these box and whiskers plots to determine which conclusion is valid. Pair B had higher scores in each competition. Pair A and pair B have the same interquartile range. Well, we know that this is 2 and this is 3, so we know that's not true. The upper 50% of pair B is exactly the same as the upper 25% of pair A. Well, here's 50% of pair B compared to 25% of pair A. Well, that's true. And pair B had less variation than pair A. So we know that C is a valid conclusion. Pair B had less variation than pair A. Pair A has a higher range and a higher interquartile range, but the lower quartile has greater variation for pair B. 14. The cafeteria workers surveyed 250 students to find out the type of food students preferred for lunch. We have our results. Based on the table, predict the percent of all students at school who would prefer chicken. Well, chicken is 40. Here's chicken, 40 out of 250. So it's asking us for the percent. Well, 40 out of 250 will give us, simply just divide these two. So 40 divided by 250 is 0.16. Well, that's 16%. Question 15. Sophia scored the following scores on her first 5 tests. If she has one more test and she wants to get a 96 average, what is a minimum score. So that's when we add all of our values together. And now we have our x. We divide it by our total number, which is 6, and we want to keep this average of 96. So we add up all of our values. So we have 100 plus 98 plus 100 plus 96 plus 89. That gives us 483 plus x divided by 6. I get rid of the 6 here, so I multiply by 6. They cross off. Multiply by 6. 96 times 6 is 576. And 5 is 576. Now we subtract 483, so we do minus 483. So minus 483, and we get 93. So she must get a 93. And 16, there's 40 employees at a company. The table shows their annual salaries. Find the mean, median, and mode, and use math to explain how you determined your answer. So I'll do this one right here. So we can go to stat, edit. I'm going to clear my list. So second plus 712. Set my memory, stat, edit. 20,000. 30,000, 40,000, and 50,000, and we have 25, 1, 5, 9, stat, calc, we want L1, comma, L2, enter. So I know that the mean is 29,500, so the mean 29,500. The median is 20,000. So the median is 20,000. And the mode is going to be also 20,000. So the mode is also 20,000. Now it says to justify how I got these, well, I know that the mean is the average. So you add up all the numbers. And divide by how many. I know that the median is the middle number. And the mode is the most common. So I found the most common, I found the middle, and I found the average. So which measure of central tendency best represents the average income of an employee working at this company? So if you're looking at the average income, well, average would mean mean, but I would say the average, you can use, if I would say the median, because this is the middle number. Okay, half the people make more and half make less, or above or below, because they actually, it's all 20,000. Or you could say the mode, because 25 people out of this survey make 25,000. All right, so most of the people make $20,000. It's actually 25 people out of 40, so 25 out of the 40 people make $20,000. So that's why the mode will work for this one. I wouldn't say the mean, because those people that are making $50,000, they pull up the average amount. So most of the people are making 20. As long as you can select a measure of central tendency and justify your answer, That's what it's asking for. And then the last one, Montgomery County survey 500 randomly selected people, find the average education, and the surveys are shown based on this about how many of the 100,000 people have a master's degree. So when we look at a master's, it's 50. So we have 50, and our sample had 500. So it's 50 out of 500 is equal to X out of 100,000. So to solve this, we cross multiply. So we do 50 times 100,000. We get 5 million, and then we divide by 500, and we get 10,000. So X equals 10,000 people. So 10,000 people have a master's degree. And then Daniel decided to go to the National Institute of Health and give the employees there the same survey. Would you expect results from Daniel's survey to be as accurate? I would say no, because more people than the NIH, more people at NIH are required to have a college or higher level education. Alright, so his survey is biased. Alright, you're not going to get accurate results with Daniel's survey. His survey is biased. These people have college level courses. His survey is biased. The people he surveyed need college level courses. Work at NIH. It's not a fair survey. Remember, it has to be random and a simple random sample. So where he's doing his survey, it's going to give him inaccurate data. And that is our Unit 5 review.